Hello everybody, welcome to my channels. So in last lecture we had been discussing the different stability of a floating body. So far we had discussed linear stability of floating body. Now we shall proceed it to the rotational stability of a floating body. So I have drawn these pictures already to save my time and yours as well. In first conditions, body is vertical. There is no rotational displacement. In the second case, I just give a little rotational displacement to the body towards right side, and in third conditions also rotational displacement was given. So let's discuss its one by one. In first case, weight of the body will be acting towards downward and buoyant force will be acting towards upwards. So as the principle of floating body, if a body floats, both the forces are equal. So it is in stable equilibrium. In second case, in this case, I just give a little rotational displacement. This rotational displacement may be angle theta. And when I give this rotational displacement of the body, the center of buoyancy B shifts towards B dash. Why does this happen? Why did this happen? Because when I rotate it towards right hand side or clockwise, the amount of the displaced fluid will be little bit towards right hand side. Again I explain, when I rotate this body clockwise, the displaced fluid will be more on the right hand side, and this portion is the extra fluid which is displaced when I rotate this body clockwise. If the volume of displaced fluid is more on the right side, definitely its center of gravity will be shifted from B to B dash. It is evident. You can imagine it easily. In this case, if this B portion, if this B point, that is the new center of buoyancy, if I draw a line from B dash to the, if I draw a line from B dash vertically upward, then you will get a point called M. And M is nothing but the intersection point of axis of body and the line of action of the buoyant force. And this M is nothing but the metacenter. So metacenter is a fixed point in a floating body, which is nothing but the intersection point of the axis of the body and the line of action of the buoyant force. I think now this might be clear to all of you. What is the metacenter? Now the metacenter has a significant role regarding the stability of floating body. In this case, M lies above G. And body retains its stability. Now what is the metacentric height? I have explained to you what is metacenter. Now the question arises, what is the metacentric height? Metacentric height is nothing but the distance between the center of gravity G and metacenter M. So Gm is the metacentric height. How to calculate metacentric height? By the figure it is clear. Gm is equal to Bm minus Bg. Bm minus Bg. Now what is Bm? Bm is nothing but I upon V. It can be proven mathematically. If you suggest me, I can prove it. How does Bm equal to I upon V? But here, for the time being, we can consider Bm is equal to I upon V minus Bg. Now the question arises, what is I and what is V? I is nothing but the moment of inertia of the surface of the floating body. I is the moment of inertia of the surface of floating body about the centroidal axis. You didn't get point? I just explained. If I draw the plan of this floating body, I get plan like this, and this is the center of gravity. And if I draw a line like this, if I draw a line which passes through the center of gravity, and this line is on the water surface, mind it, this line is on the water surface, then I is the moment of inertia about this line, because body is tilting like this. So I is the moment of inertia of the body about the centroidal axis on the water surface. I think it will be clear. M is nothing but the immersed volume, as I have explained in earlier lectures, and Bg is the distance between the center of buoyancy and center of gravity. Now the important point is that in such scenario, in this case, when M lies above G, Gm is positive. In this condition, Gm is positive. In other words, you can say M lies above G. So this is the positive metacentric height. And when the metacentric height is positive, the body is in stable equilibrium. Always remember, when Gm is positive, like this case, body in stable equilibrium. Why? Why does this happen? Why is body in equilibrium? Because in such conditions, weight of the body is acting towards downward, and the buoyant force is acting from the downward to upward, like this. This is buoyant force and this is weight. And when I give a little rotational displacement to the body, this buoyant force will be acting towards upward and this weight will be acting towards downward, and these two forces make a couple, and this couple tries to bring the body back into its original state like this. That's why we call, in such scenario, in such case, Gm is positive, metacentric height is positive, and body is in stable equilibrium. I think this might be clear to all of you. So this is the case when Gm is positive or positive, body is in a stable equilibrium. Second case, in this case, M lies below G. That's why Gm is negative, because if you subtract Bg from Bm, Bm minus B, so definitely Bm is shorter dimension and Bg is a larger dimension. Definitely Gm will be negative for such case. So in such case, metacentric height Gm is negative and body is in unstable equilibrium. What does happen in case of unstable equilibrium? Just concentrate. In this figure, you can easily watch that weight of the body working downward at this point G, and this is the center of buoyancy. Buoyant force will be acting through the center of buoyancy in this direction. In this direction, buoyant force, and in this direction, weight of the body is working. So in such scenario, these two forces will try to bring body more clockwise direction, in the further clockwise direction. And if this couple acts in the clockwise direction, body will sink into the water or fluid, whatever it is. Okay, so in this case, restoring couple works, which tries to bring body back into its original state. In this case, In this case, the disturbing movement, you can say it, in this case restoring movement, and this case is, again I explained it, in this case always a restoring couple works. What is restoring couple? Couple is always force into distance between the forces. Then force is equal to W. And what is the distance between force, both the forces? That is this distance. So if this theta, that is gm cos theta, and this value is gm sin theta. So in this case, restoring couple works, and the value of restoring couple is equal to W multiplied by gm sin theta. In this case, M lies below G. A destabilizing moment works which tries to sink the body back into the liquid, and value of the destabilizing couple will be same, W into gm sin theta. So in this case, this is the case of unstable equilibrium, because the couple made by the buoyant force and the and the weight of the body will try to sink the body into the water. And the last and third case is that when M coincides G, means M lies exactly above G. In that case, metacentric height will be 0 and body will be in neutral equilibrium. Neutral equilibrium. In that case, metacentric height is 0 and body is in the neutral equilibrium. And no moment work in such condition. No moment work. If metacentric height 0, no movement work. Body is in equilibrium condition. If you tilt the body in that direction, body will remain in its in that position. If you tilt the body in that position, body will remain in that position. Okay, there is no restoring couple or destabilizing couple. I think these two terms might be very clear to you. Now you people might be confusing that sometime I put G above B, sometime I put G above M or below G. In each the cases I vary G. Now you people might be thinking G should be at the center of the body. It is not necessary. I can vary G in its centroidal axis anywhere. But how? If I put some weight on the downmost portion of the body, G will be shifted towards downward. If I put some weight on the upper portion of the body, G will be shifted towards upward. So G can be the position of the center of gravity of the body, can be varied above and below on the its centroidal axis. There is no problem. Okay. There are the three cases. Now what is the application of these cases? You might have seen a ship floating on the sea or on the ocean. See, if it rotates, then it again comes back into its original state very easily. Why does this happen? Because in that case, metacentric height Gm is given positive. In other words, in that case, M always lies above G, sufficiently above G. So, larger the value of the Gm, larger will be the stability of the floating body or the ship. So, to make the value of Gm larger, we always try to put some weight on the bottom of ship so that the center of gravity body will be lying comparatively at lower portion, and Gm will be the larger. As the Gm will be the larger, greater will be the stability of the ship. I think these all the topics, metacentric height and center of buoyancy, might be clear to of you. If you find any hindrance, any problem, any doubts, you can ask me in the comment sections. I can make one more video if you do not get these terms very easily. These are very interesting terms. and I explain each and everything to you. So next time we shall discuss some other complicated topic in the domain of civil engineering. You people can mention those topic on the comment section, whatever topic you feel very complicated and you will be facing trouble to understand those topics. I can make video on those topics. So just give your opinions on the comment sections and suggest me the next topic for which I should make video to make you understand. Thank you very much.